Hello, ladies and gentlemen, Mr. Eicher here, coming with a video about probability and statistics, final exam review for your exam coming up. We have an AP Stats teacher wonders if there's a relationship between the month a student is born and how they perform on the AP Stats exam. He collects data from 6 prior years. Excuse me. And records the month the student's born and puts it into either a birth month grouping like January to March, April to June, 3-month groups. So there are 4 groups. And if they passed or did not pass the AP Stats exam, the data is summarized in the table below. So we got that table. Going to answer some probability questions. So first we have, what's the probability the student passed the AP exam? So we need to know how many total passed, 194. And how many total took the exam, 211. And as the directions say, you can leave your answer as an unsimplified fraction. So there it is right there. Now just out of interest, let me calculate this. That's a 92% pass rate. So kudos to those many students who did a fantastic job on the AP exam. Letter B, what's the probability that a student is in the January to March birth group? So January to March, we need to know how many total January to March students there are. There's 47 out of the total 211. So that's about a quarter of the students, which kind of makes sense, right? Because there are 4 groupings, so you'd expect about a quarter in each group. Letter C, what's the probability a student is in the January to June birth group, birth month groups? So we need January to June. So we're going to add all of these together, which is 99. So there are 99 students in one of those 2 groups. 99 out of 211, which is about half. What's the probability a student is in the October-December birth month and that they passed? So we're going to look in October to December birth month and they pass. That would be 57 out of 211. Letter E is a conditional probability. This conditional probability, you know it's conditional because it says given. The next several are going to be conditional probabilities. So it says given that you select a October-December student, what is the probability the student passed? Now these are the kind that I really like because I get to erase a lot of the table with conditional probabilities. Given that you select a October-December through December student, so we're going to ignore all these other students who are not October and December. And we're going to look at just this grouping. And given that they're October, December, so there are 59 of them, what is the probability they pass? That would be 57 of them out of the 59 passed. And then the next question, given that you select a July-September student, so we're going to ignore everybody who's not July and September. So that would be all these people. So we're only looking at these people. What is the probability the student passed? So July, September, there's 53 of them. How many of those 53 passed? There's 48 out of 53. And then letter G, given that you select a student who passed. Now this is going to be a different way. Before we were going kind of horizontal in the numbers that we're looking at. Now we're going to be going vertical. So given that the student passed, so we ignore all these people who didn't pass. These total numbers are now all different. So we have, given that they passed, there's 194 who passed, 194. And what's the probability they're in the October to December group? So that would be 57 out of 194. And terminology that I'd like you to be familiar with are the events January to March and April to June mutually exclusive? We would say yes, they're mutually exclusive. You can't be both. Can't be in both groups. both groups. They're excluded from each other. If you're born in January, you can't also be born in April. So these are mutually exclusive events. And then letter I says, what's the probability of selecting a student who passed? Let me get rid of some of these eraser marks. What's the probability that a student passed or is one born in October, December? So probability that they passed, that would be this many students passed. Or they were born in October to December, that's this many students. But you might realize that these events are not mutually exclusive, which is really important. You have some students right here. These students would be counted as both passing and as October to December students. So because of that, we're going to have 194 plus 59, and we subtract these 57 students who we double counted. So we have to add up all of those and then divide by 211. Sorry, I kind of ran out of space there. So you're going to have 196 would be the answer. That would be 194 plus 59 minus 57 is 196 out of 211. Now we're not subtracting the 57 because we don't want both to happen at the same time. We're subtracting the 57 because we counted them here and we also counted them here. So you shouldn't double count those 57 students. If they're counted as passing, you shouldn't also count them again as October to December students. So you should get 196 out of 211. And then these last set of questions are based on the same two-way table. We have, suppose we select two students at random from those represented in the table. What is the probability that both students pass without replacement? So the main point here that I'd like to review with you is what it means without replacement and with replacement. So if we have student that pass without replacement, we have two sets of parentheses, one for each student represented. So if we randomly select a student who passed, that's 194 out of 211. And if it's without replacement, when we go to pick a second student, we have one fewer to select from. We don't have 211 anymore because we just picked one. We have 210 left. And then the numerator also will change since in this first set of parentheses, that represents picking one student who passed. There's a 194 out of 211 chance of getting a student who passed. So that would be 193 out of 210. These we'd like you to multiply. So we'd have 194 over 211 times 193 over 210. So the answer I get rounded to four decimal places, like you were asked to do right there. The answer I would get is, I'll write it over on the left. Ooh, but not with that type of writing utensil. 0.8450 would be the probability that both of them pass the exam without replacement. What would it look like if it was with replacement? Well, if it's with replacement, you could get the same student again. So you'd have 194 over 211 and then times 194 over 211. These are independent events, they're called. The probability doesn't change. So we'd have 194 over 211 multiplied again. So you get 8454 as your answer rounded to four decimal places. So it's a pretty close probability that we had an A, but it is slightly different. And that's with replacement compared to without replacement. Again, with replacement is you're replacing the person back after you've selected them the first time. It's kind of like a die roll. Once you've rolled the die and gotten a 5, you could roll it again and get a 5. And it's the same probability of getting a 5 each time. Letter C, we have, what's the probability of selecting an October-December student, then a July-September student without replacement? So October to December, we had 59. And then July-September, we had 53. So we have 59 out of, excuse me, 211. That's the probability of picking a October-December student. And if it's without replacement, we're going to have one fewer student, 210, when we go to pick our second student. And the July to September students, July to September was there 53. Now notice that numerator is 53. The first time we chose, we picked October-December student, 59 of them. The second student we chose, we still have 53 July to September students. So we would have 59 divided by 211 times 53 over 210. And that would be without replacement. Without replacement. So our probability to 4 decimal places, it's much less likely that you would get October, December, and then a July, September student. And then same idea, same question, just this one is, excuse me, with replacement instead of without replacement. So we would have the October, December, there's 59 out of 211. And then a July to September, there are 53. And since it's with replacement, our denominator is 211 rather than 210 like it was earlier. So we have 59 out of 211 times 53 out of 211. So we get an answer of 0.0702. So pretty close. Both of these probabilities with and without replacement, excuse me, depending on the sample size, 211, since it's pretty big, depending on the sample size, they'll probably be relatively close to each other, but they don't have to be as close as they appear here. Sometimes they're pretty different. So thus ends the probability review. Give me a thumbs up if that was helpful for you. And thanks for watching. Great job on reviewing prob and stats.